Hey, it's Adam, back with some more code. This time we're doing the homework for Nibbles. That's right, I'm doing your homework. At the end of the Nibbles tutorial series, where we built the snake game in C++ and SFML, I set some homework tasks for you guys to do, hoping you'd do them and share them with me. I thought it might be cool for me to do them and just show you how I would approach these problems. Most of these won't take very long, so let's see what we can get through. Let's go through them first. So the first one was change the number of apples required to progress to the next level into a variable in the engine class and change it to 5. So right now, the number of apples required to progress to the next level is a hard-coded magic number. We want to change it to a variable so we can easily change it. Next one is make it so speed only increases when you load a new level instead of when you eat apples. Start the speed a bit faster though, or the first couple of levels will be quite slow. So right now, when you eat an apple, your snake speeds up, and when you load a new level, it speeds up. It reverts back to the default speed plus a little bit more. So what we want to do is make it so each level is all the same speed. The difficulty is just from the length of the snake and progressing to higher levels. The next one is add a couple of cheat keys. So these will go in our input section. Some ideas are spacebar to add more sections to your snake, M to move the apple, and L to just go to the next level. The next one was, can you find any code that we didn't actually use in the project, or do you have any ideas on how to improve the code? I've got some ideas, but I'd love to see yours. So we'll go through that. There's a couple of things I want to tidy up, and one thing in particular that we didn't use at all. So that'll be good. This one is your choice, surprise me. My idea for that one is I might introduce an actual sprite into the game, and instead of the red square for the apple, I'll put a little coffee cup, so our snake will go around picking up cups of coffee. I won't do that in this video, but if I get around to it, I'll post it in the forums. So come join the forums at forums.caf.tech and hit me up if I haven't done it yet. Now the bonus, this one's going to be the longest work, I think. It is change the level files. We've got these text files that show how the level is built. Change the level files so you can set the starting position and length of the snake. You could use the H character to denote the head and the S character to denote the body sections. Then in the engine, build a function to load in the snake from the level file. The trick will be to work out how the snake connects. Some loops will be required. With this, you could make some levels super hard by starting the game with a really long snake. Yeah, so our level files are just these things with the walls. X denote a wall section. So you could make it so you could have a big long snake starting there. You could place your snake wherever you want so that you can have walls anywhere. And you'll also want to be able to set the starting direction of your snake. I've already thought about this. I've already tackled it in another project, so I'll show you how I did it, and we'll go through and implement it in C++. So there are our homework tasks. Let's have a look at them. First one, change number of apples required to progress into a variable. So if we look at update and look at the collision on apples, here it is, apples eaten this level. If it's greater than or equal to 10, then we progress to the next level. This is our magic number we want to get rid of. So over in engine.hpp, let's add another variable. Now this can just be a constant like our FPS. So const unsigned int apples. What are we going to call it? Apples for next level, I guess. And we'll just set it in here. Let's, just for testing purposes, let's set it to 3. So we're declaring a const, so this variable can't be changed. It's only set in here. So we'll set it to 3. Now in our update, let's get rid of this magic number and go apples for next level. So if apples eaten this level is greater than or equal to apples for next level, then we'll move on. I think that's as easy as it is for this one. Let's try it. We've set it to 3, so we'll fire up the game. Slow to start with. Maybe someone will add some music to the game for us and sound effects. That'd be cool. All of that stuff you need for adding sprites and music is all on the SFML website. There we go. So we ate 3 apples and went to the next level. Now, because we've only got 2 levels, after we eat 3 apples on this level, it should just continue on. So that's 3, and we're still here. 4. There we go. Nice. So that one worked. Awesome. Let's mark it as done. Move on. Make it so the speed only increases when you load a new level instead of when you eat apples. All right, start the speed a bit faster though. All right, so in update, this is the same section, collision on an apple, as when we were increasing the speed. So speed plus plus, let's take that out. Let's actually comment that out, just so we don't lose it. Move the speed increase here for homework. There we go. Now, what we need to do is when we begin the next level, we want to increase the speed. So that'll be in engine. Move apple, new snake, begin next level. Here we go. So normally when we begin next level, we set the speed back to the default magic number of 2 plus the current level. Let's set the default speed to 4. So every time we go to a new level, let's go speed plus equals, let's add 2 to it. So it'll start at 4 and then we'll add 2. So that means up here at start the game, I'll set that at 4. So level 1 should be at 4, level 2 should be at 6. Let's give it a quick go. So it's clearly a bit faster when we first start the game. It's not getting faster when we eat apples. And it's even faster when we started the second level. So that one's done. Nice. Easy ones, right? I told you they'd be easy. Right, add a couple of cheat keys. These should be easy too, because add snake section, move the apple, and load the next level are all functions that we can call right from our input. So we're going to look for space, M, and L. So in our input, we're grabbing key press events, quit, pause, new game, direction. Let's put it above the direction stuff so it's all at the bottom. Cheat keys. So add snake section. If, no, event event.key.code is equal to keyboard space. Then we just want to sections to add plus equals. How many sections do we want to add? Let's add 4 every time we hit space. The next one was move apple. Let's just copy that little bit there. Move apple, blam. We've got a function for that. Move apple. I'm going to change the key to M. Nice. Load next level. If event.key.code. You don't want to be copying and pasting all the time. Your fingers remember easier if you type it a fair bit. The more you type it, the easier it is for your fingers to remember. And the quicker you get at typing this code. So I think a function is called begin next level. There we go. I think that'll work. So there's our making a snake longer. Now if we hold the key, keeps adding them. Ooh, we held it for a long time because our operating system repeats the key press. All right, move apple. That works. Load the next level. Bam. That'll work. That's pretty cool. If you don't like where the apple is, just move it. Nice. Another job done. Can you find any code that we didn't actually use in the project? Let's look at that first. I know for one in particular. Right up the top here. We didn't get around to using this time per frame thing. This is here because I copied it out of another project I was working on, making another game with SFML, and it required it for smooth scrolling. It's to smooth out your scrolling and your physics. But we didn't use it. It's still grey. Field time per frame is never used. So we could safely delete that. And also in our HBP, it's declared in here somewhere too. There it is. That was never used. Now also in our homework, it says, do you have any ideas on how to improve the code? Now one thing I thought of, see our wall sections that we're using to create all the walls on our level. It's only got one private member, which is the shape of the wall, and one function, which is getShape. We can do everything we need with getShape. That if we need to check for collisions, we can use getShape and then intersects or getGlobalBounds to find exactly where it is. But if you have a look at snake section, it's got, hang on, where's the HBP? It's got position. Section is the actual shape. Position is a variable we're using to set and get the position. We've got functions here, get position, set position, and also update. If you look in here, all update does is it sets the position of the shape to the position in that variable. Get position just gets the variable, and set position just sets the variable. So why don't we drop all of this, and if we want to move this snake section, why don't we just do it directly to the section, the shape. We can leave set position, but make it manipulate the shape directly instead of this stupid variable. So what we need to do, I think our apple is fine. Apple has got shape, set position. Yeah, so we want our snake sections to be more like the apple. If we have a look in engine and look at where our move apple function, move apple, we've got collision checking. So apple.set position, new apple location. If we look at apple.cpp, set position changes the actual sprite, the shape position directly. That's what we want our snake section to do. So let's look at it. Let's just change this function first. So we'll get it to do this. That, and use new position because that's the one coming into the function. So that'll directly change the section. So we've updated set position. We want to get rid of anything to do with get position and also update. Let's do update first. So if we look in our project for dot update, here we go, s.update. It's only used in one place. Run snake update functions. We don't need to do that because we'll be moving the thing directly. See up here we were updating the positions. Set position. This will be doing it directly. Alright, so update, get rid of it out of our HPP, get rid of it out of our CPP. Right, one step closer to being tidy. We need to keep get shape, but get position we don't need anymore. So let's look that up. Dot get position. So snake, snake, snake. So it's in engine and update twice. So in engine, add snake section. What are we doing here? We're adding our new snake section to the position of the last snake object. So there's actually a cooler way to do this. We're going snake.size -1 to get the last index. I believe we can actually go snake.back. That will give us the last item. Now instead of get position, let's go get shape dot get global bounds. That should get his position. It returns a float rect. So let's change this. Rect. Yeah, there you go. See, it's not complaining. So new snake position. This is not actually what we want to do. We'll keep this one. It's a vector 2f. So rect, we'll call this last section rect, get rect. So equals vector 2f last section rect dot x. Is x what we want? Dot with left height top. Left should be what we want. Left. And last section rect dot top. So that should be x and y. It's a little bit complicated because it says left and top. I think that'll do what we want there. Let's go back here. Where else do we need to update this? Let's copy a little bit of code here. Alrighty, update. We're getting the position of the snake's head. So we're using snake 0 here. You can change that to snake dot front to get the start of it. If we have a look at c++.com under vectors, see there's back, returns a reference to the last element. And it's begin, not front. Oh no, it is front, sorry, front. Returns a reference to the first element. So while we're here doing this, let's just update that. Front. Let's just paste our other code in. Front. Get shape, get bounds. Let's go. This section position equals that. And we can delete that one. There we go. There's one more place. This section position equals same thing again. Bam. So you want to go snake s dot get shape dot get global bounds. We don't need to declare that because we already used it. That should work. All right, back in our snake HPP. See, get position is grey now. It's never used. Let's delete it. Get position. Bam. Now, do you think it'll work? Let's try. Got no errors. Snake's moving and updating. Let's do a collision. Works. Let's collide with ourselves. Bam, works. Let's collide with the wall. Right, so it's able to get the position without our get position function. So that's all we need to do in snake section. Nice job. We can close wall, we can close Apple. Let's look at our homework. We got rid of some code that we never ever used, and we got rid of some extra functions that we didn't need in our snake section. Just tidy it up a little bit. They weren't causing any problems, but they were redundant. Your choice. I'll do that off camera, and I'll post it in the forums when I get around to it. As I said, I'll probably make sprites, little coffee cup sprites that the snake will pick up instead of the red apples. Now the bonus, change your level files that you can set the starting position and length of the snake. Now I mentioned that I've already tackled this. I'll show you. I've been playing around with Godot. It's a engine and game development IDE. You can build 2D and 3D games in it. So I've just been learning it, and I thought I'd just make the snake game again just to help me learn it. It's probably a mess because I haven't gone through and tidied it up. But this is the load level function, and this is an idea of how it's going to work. It's looking for the X for the walls, but it's also looking for these other characters to set the directions, to set the snake head and the tails. I'll show you a level file. For some reason I can't open these level files in here anymore. I think they worked the first time, but I can just open them in a text editor. So that looks almost identical to the other one that we were doing in C++, but you can see we've got the head there and the tail sections, and I've just put the direction here of down. That can be anywhere within the field. It'll still find it. I just put it there because it's handy. So this is the sort of thing we want to do in our project. And then we also want to replicate this function here. It's checking for these. It's got a variable for the snake head. So when we find the head, we'll put the coordinates in for that. And as we find snake tail sections, we'll put the coordinates into this array here. And then we build our new snake out of the head and the tail. And then back in the game, it takes this new snake and builds our actual snake out of it. So it clears this snake when we start a new game. It puts the head on there that we got, and then it gets the coordinates for that head, and then it pops that section off of the new snake. This is Godot, so it's closer to Python really. And then we iterate through our new snake. We're using a while loop here, so while the new snake has size, so while there's still sections in the new snake, we'll check them out. So we'll just infinitely loop through this thing until there's no more new snake left to pull apart. We've got a boolean here. Have we found a new section to add? And then it does check if the section is next to the last section. So the last section at the moment would be the head. So snake is the one that we're building. New snake is the one that we got from the level file that we're pulling apart. And as we iterate through it, ns is the new snake section. So if ns.x minus the last section of our actual snake.x divided by 20 to get the actual coordinate is equal to 1. So we've got an absolute value here, so it will always make it 1 instead of -1, so we don't get confused. So if it's on the x coordinate, if it's right next to it on either side, then check if it's on the same y coordinate. And if it is, then let's add it. Now this one checks if it's 1 away on the y coordinate, so top or bottom, but also on the same x coordinate, then it'll say let's add it. And then down here, if we're adding this section, then we push back onto our actual snake, a new instance of the snake section, and then we set the actual position from what we just fetched up here. And then Godot doesn't have a way to just pop the last section off of an array, so this is what we had to do here with two things. We'll be able to do it a little bit easier on C++. But anyway, we pop that section. Oh, actually, we're not popping the last section, we're popping that index. So we're popping that index off of that new snake so that this thing eventually will fall through because there'll be no snake left. It was a long explanation, but hopefully you'll understand it as we build it in C++. So the first thing is look at our level file. Let's set our direction down. Let's make sure we always fix up our wall sections as well as we add new characters. Now let's set our head here. Start setting some tail sections. 1, 2, 3, 4. Let's let it come down a little bit as well. So it should be 7 sections long, the snake. All right, so that's level 1 done. Let's have a look at level 2. Actually, let's make level 1 go right instead of down. let's make level 2 go down. And let's set our head section here. Put some tail here. There we go. So now we need to build the functions that understand what these mean. So in engine.cpp, we've got our load stuff down the bottom, I think. So check level, files, load level. All right, so we've got our for loops for the y coordinate and the x coordinate, same as we do in go dot y and x. But here we're looking for x. We want to also look for other stuff. So else if line x is equal to, let's do our directions first. Let's start with right. I've been writing these other languages lately, like Godot, and I've been learning Python as well. And I've also been programming for Commodore 64 in Turbo Rascal, and their statements are a little bit different, so forgive me if I type the wrong thing briefly. So if we find an R, then we want to set snake direction equals direction, right. No, didn't we make a thingy for that? An enumerator? Yeah, direction. Direction, right, there we go. I must have typed it wrong. Let's do some copy and paste, because this is just a little small section. Right, make that down, left, up. Now fix them. Down, down, left. Whoop. There we go, so it should be able to get the directions now. Now, we want to also check for heads and tail sections. But first, we want somewhere to keep them. So we want a vector. Actually, the head section will be a vector itself. Call it a vector 2f. Might as well just use that. Call it new head. And then we'll need a vector of vector 2f's to hold our tail sections. So we'll call this new snake body. Normal vector doesn't start with a capital V. There we go. Cool, and let's create our vector that will hold our entire new snake. It will be vector 2f's new snake. It's a good idea to create your variables at the top of your functions, so if you need to make changes, you know exactly where to find them. So, else if line x is equal to, let's go h for head, we'll go new head equals vector 2f of x and y. There we go. Now else if line x is equal to tail, then we want to go, what do we call it? New snake body dot push back vector to f x y. Oh, that's right, we don't do push back anymore, we do in place back in C++. Can't remember why that was. There was a change. Apparently that's better to use. All right, so right, down, left, up, head, tail. That's all we were grabbing out of the Godot thing. Right, down, left, up, head, tail. Now we need to build our snake, our new snake. So after we've closed the level file, build the new snake. So new snake dot and place back how were we doing it before? Add snake section, place back. New section position. Oh, right. And I've lost it already. Snake. Yeah, so snake dot and place back. It's going to instantiate this new thing. So maybe we should just create this directly. Down here in our load level, let's just clear our snake. Snake dot clear. Bam, he's gone. That way we don't need a new snake. So snake dot and place back. We want new head. That's a vector 2f. That should work. Now, because we are instantiating sections of the snake sections, we're going to have to iterate over our new snake body. So for b of this isn't right. I'm not doing it right. I told you I've been doing all these other languages. New snake body. Let's just type it out and work out what I need to do later. Quickest way to find that will be in draw for auto s colon snake. Right. So auto b colon new snake body. There we go. So you want to go snake dot. Wait. No, this is where we need to build out this bit here, this big iteration here. So we want to do a while loop. So instead of that, because what we've got is just a random collection of snake body sections. So it reads the level files this way, across, 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 across. So the first snake section it's going to see is a tail, and then it's going to go tail, 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 and then head. And then it's going to see a tail all the way down here and then here. So the very first part of the body would be this one, which is not right. So we need to do a while new snake body dot size. We can do the same thing. The empty method should be, yeah. Check for emptiness instead of size. Right. That's even better. So while not new snake body empty. See how handy C-line is? Gives you these little tips. The other way would have worked. All right. Let's look at this. So we're iterating through the snake sections like I was about to do. So for auto, let's just call it the same thing. New snake body. Doke. Then we got a boolean. Add this section. Probably don't need to declare it every single time. Now I know I just said put all your variables at the top, but because this is only ever used inside here, I'm comfortable putting it right above where you use it. That way you don't have to scroll all the way to find it again. So we want a bool add this section equals false. We'll initialize it at false, and then every loop will also add this section equals false. We'll also reset it to false. And then we need to do these absolute checks. So I'm just going to copy this. I know it won't work in C++, but I'll just throw it down here. It's going to complain about it, but it'll give me something to look at. All right, so if, now think in C++ to do an absolute, will it let us do it? Abs, no matching function, yeah. So I think we need a math.abs. Is that not right? Abs. Turns the absolute value of a parameter. So we need standard lib. And then we can just use abs. Nice. See how handy this bloody site is? So in our header, let's include standard lib, standard library. Now we can use abs. ns.x minus snake dot back dot get shape dot get, remember we did this before, get global bounds dot left, a lot of typing, divided by 20 because our snake sections are 20 wide, and our map is divided into, each section of our map is actually 20 pixels. If it is equal to 1, then also check if ns.y is equal to this dot top divided by 20. Top divided by 20. Then we're smiling. Add this section equals true, baby. Now we can do it else if here. Do another absolute for the y. So it's basically this. But we're going to check against y and top. And then we're going to do basically this, except we're checking x this time, and instead of top, checking the left. This section, now back over here, add this section. All right, we've got this part here. If add this section equals true, then we add the new section and drop that one off of our new snake array. So down here, if add this section, do some stuff. Let's add some comments in here so we can remember what's going on. Check, actually, before we forget, let's get rid of this little bit of temporary code here so it doesn't throw any errors. All right, check if new section, check if this section is beside the last section. Check if this section is directly above or below the last section. Okay, so this is where we want to do our snake dot and place back. And we're going to need a vector2f of ns.x, ns.y. Bam. Now we need to get rid of this particular snake section. Now, what's the best way to do that? Yeah, all right, so it looks like you can't use the index. Okay, so we'll have to change this. Because we need to be able to erase at a particular index from that snake body, because we're pulling things out at random. We're looping through until we find something that matches up with our last section, and then we need to be able to pull that out. And because this range-based loop doesn't give us the index, we can't use it. So let's go for, let me just remember how to do these. Int, I'm going to call it I equals 0. I is less than new snake body dot size I plus plus. Get rid of that one. Now everywhere we've got ns, we have to change that to new snake body and then the index, like that. So ns blam And then we can go erase I. Is that not what we want? Oh, it wants an iterator. Position iterator pointing to element to be erased. Oh, okay, it's new snake body dot begin plus I. That should do it. Oh, we're going to O red lines. So let's just go over this again. We've created somewhere to store the new head when we find it. We've created somewhere to store the new body sections when we find them. This will just be a random jumbled collection as we discover them on the level file. We've created. We're checking for the directive in our level file, and we're checking for the head and the tail sections. Now, if you wanted to be silly and create multiple head sections, then only the last one that it finds would count. And if it doesn't match up with any tail sections, then you're going to get some funky looking snakes. Maybe don't do that. Then down here, after we close the file, we declare this, add this section, set it as false. We put put the head section on our new snake, on our actual game snake. And then we do a while new snake body is not empty. This is a continuous loop. If we don't pop things off of that new snake body, this will never end. So it's important that we did this erase thing down here. I just thought of another avenue for a bug to arise. If you created a tail section that wasn't connected to anything else, then this loop would never end and the game would crash. So at some point, maybe future homework would be in our check level files function, maybe it'll validate whether the snake looks good. Maybe in here we can check each section to see if it actually has another section around it in the level file. And then if it doesn't, just discard it here so we don't get stuck. Anyhow, we check if the section that we're looking at, we're iterating over every section in our new snake body. We're checking if it's horizontally beside the last section on our good snake. And if it is, we check if it's on the same Y coordinate, so if it's horizontally beside it. And if it is, then we say, yeah, let's add this section. But if it's not, we'll check if it's vertically beside our good snake, so if it's above it or below it. And if in this iteration we've found that we can add this section, then down here we add a new section to the end of our good snake, grabbing the X and Y from our new snake body, and then we're removing that section from new snake body. So it'll gradually dwindle away until new snake body is empty and this while loop can exit. So I think that will work. We're setting the direction. We're creating our new snake. I think it'll work. Let's hit the play button and see if there's any errors. We've got no errors. Whoops, and we've got a new snake. I accidentally resized my window. That doesn't look like the right snake though, does it? I think that's because what we're actually doing is declaring our new snake up here, see? New snake. Let's find where we're using that. Let's look for that one. So it's called up here in start the game. Let's not call it anymore. Just comment it out for now. New snake. It's called on begin next level. Let's not do it there. All right, so now we should be using the one from load level. Let's go. We got a problem. Game over. It's up in the corner there. That's because we didn't adjust the 20 pixels for each of the level pixels. We can fix that. Right down here where we're placing our new snaky bits. Snake dot and place back new head. X times 20, Y times 20. Right, so that's the head section fixed. Down here where we're adding our tail sections, we'll do it times 20 times 20. That should do it. Nope, still game over. It's up in the corner. Yeah, set position. Yeah, here's an error here, look. That's what we forgot to get rid of before. That position variable. Not that it's causing the problem now, but we don't need it. I think I know. I think it's this reload CMake project. Because we changed these files, it hasn't updated them, it's not rebuilding them. Yeah, there we go. Yeah, it works. So with the direction, we've got all the snake segments. They're all joined up, not silly. Cool. So there wasn't a bug in this code. It was simply that I hadn't reloaded the CMake project because I'd made changes to these level files. When you make changes to a file that's not code, an asset file, you need to reload CMake project just so it can see that those files are changed and it knows that it needs to rebuild. Cool. So that's the bonus done. With that, you'll be able to add heaps of levels and make them as difficult as possible. Making a snake start in all different ways. You could even have some sort of speed variable as well. Obviously, it'd have to be a single digit. So you could set the speed factor of the snake for that level. All right, that's our C++ homework done. Good job. If you've had any trouble with any of this or you'd like to show off your game, come join us on forums.caf.tech. You can ask for help on there or just simply show off your homework, what changes you've made to the game. Give me ideas for other videos. Check out some of the other stuff I'm working on. Remember to tickle that subscribe button and hit the thumbs up. And if you're able, check out my Patreon or Ko-fi page. Your support's greatly appreciated. Thanks for watching. Stay caffeinated.